Lasers? Really? To change the weather?
That's right. Well, as Mark Twain once famously said, everyone complains about the weather, but no one ever does anything about it. Well, instead of doing a rain dance, we physicists are firing trillion-watt lasers into the sky to actually precipitate rain clouds and actually bring down lightning bolts. This is potentially a game changer.
But this is experimental.
It's experimental. However, in the laboratory so far it works. When you have water vapor and you have dust particles or ice crystals, you can precipitate rain. It condenses around the seeds. These seeds can also be created by laser beams. By firing trillion-watt lasers, you rip apart the electrons, creating what are called ions, and these ions act like seeds, like dust particles, bringing down rain and even lightning.
Go ahead.
This summer?
This summer.
You succeeded in increasing rainfall?
South of San Antonio, we had aircraft flying on a dozen days in the month of July, treating what we deemed to be seedable storms.
And what was the result of that?
The same result that we've seen since it started in 1997. Some clouds respond very well. Some clouds respond only to a limited degree. Maybe one or two instances when clouds didn't respond as we had hoped, probably because we got to them too late.
And when you say they responded very well, what does that mean?
It means that the storm lived longer and produced more rain over a larger area.
And how do we know that it did that? I mean, what if you hadn't seeded? I mean,
good question. We know that because we systematically analyze on a given day clouds that are seeded, and we compare their behavior with similar clouds in areas adjacent to the target area that were not seeded. And we compare the behavior of the two sets, the treated and the unseeded. And we've been doing that for about 10 years now. And we have seen a very consistent response from storms that were seeded in a timely fashion.
Okay, all right. And talk to me for just a minute about what seeding is.
Seeding involves the release of a material that includes silver iodide, whose crystalline structure is almost identical to natural ice. In a typical cumulus cloud in the summertime in Texas, there are a limited number of natural ice crystals in a growing storm. And seeding is designed to increase the number of nuclei. These are tiny specks around which cloud water coalesces to form a raindrop. When you introduce silver iodide crystals into a thunderstorm, a young thunderstorm, that may only live 20 or 25 minutes and produce maybe 1/4 of an inch. If you introduce those ice crystals early enough in the life of that cloud, more of the cloud water will be converted into tiny snowflakes, which will then attract more cloud water to form raindrops. Seeding is designed to nudge the cloud along, giving it the ammunition it needs, to make more use of the cloud water that's there.